Now let's talk about the experiment we need to finish today. So, first circuit is a RC circuit, and let's see. So first step, we need to measure the internal resistance for the capacitor using the LCR machine. We will need to explain to you how to use this, but in the lab. But if you are using Tinkercad, just put the theoretical value. For second step, we need to build the circuit. Um, if if you're in person, the internal resistance for the function generator and capacitor already exist, so you don't need to put them here. But if you're using Tinkercad, you need to put a 50 ohm resistor for the function generator and a 10 ohm resistor to be the internal resistance for the capacitor. Next, we just set the function generator. Remember, this is amplitude voltage of 5 volt. So when you set it, it should be 10 volt peak to peak. Next, we use the H bars to determine the maximum amplitude. And next, determine the time constant using this equation, which is R total multiplied the capacitance. Remember, this R total is all the resistance in the circuit, which include this 1 kilo and the internal resistance for the function generator, 50 ohm, plus this 10 ohm. Next, we use the charge equation to compute Vc at t equal to tau. So all we need to do is let t equal to tau, and V battery. Remember, V battery should be the peak-to-peak value, so it should be 10 volt. And then we just do the calculation, and the result should be around 63.2% of the V battery. So simply, it's just 6.32. I already told you the answer. And in step 7, suppose we do not know the tau value and use this equation and the V bar on the oscilloscope to get an approximate value of the time constant. So if you build the circuit right, it should be, the wave should be like this. So see, this is charging and discharging and complete the cycle. So how to find the time constant on the oscilloscope? As we mentioned here, so when the amount of time equal to tau has passed, the capacitor will reach a voltage equal to 63.2% of the source voltage. So we just need to find the voltage that is 63.2% of 10 volt, which is 3.32. So we need to find a point where the voltage is equal to 6.32, and we find how much time it has passed on the x-axis. So we have this point, and we use the vertical bar to put one at the beginning of the charging and put the other at the 3.32 volt point. And the difference of the vertical bar are the time constant. Go back. Then for step 8, we calculate how many time constants are needed to charge a capacitor to reach 99% of 10 volt. So we just divide this V battery to the left, use this equation. So we divide the V battery to the left and let this part equal to 99%, and you calculate T, the result will be what we needed. In circuit 2 is the RL circuit. So basically the same for step 1, step 2. Step 3, we change the site of frequency. Then we calculate the time constant. Again, this R total is the total resistance of the circuit. So it should be 50 plus 100 for the inductor and 1 kilo. And measure the maximum amplitude. So just from here to here. And answer those 2 questions in the Canvas quiz. That's all for